Hi, in this video we are going to talk about homogeneous catalyzed reactions. What do you mean by homogeneous? Homogeneous meaning everything is in the same state of matter. Okay. Another term here, over here is the catalyzed. It means there is catalyst involved. Okay. A good example of this homogeneous catalyzed reaction can be, like let's say for gas phase, the example would be in lead chamber process. Lead chamber process is a process which was used in manufacturing of sulfuric acid. So we have an important step when we want to manufacture sulfuric acid. We want to convert SO2 to SO3. Okay, so to do that, everything is in gaseous state. We require one catalyst, that is NO. Okay, the presence of nitric oxide as the catalyst. So the reaction becomes 2SO2 plus O2 gives, in the presence of NO, it gives SO3. This is one gas phase example of homogeneous catalyzed reactions. So everything is in gaseous phase. Another example in, let's say, liquid phase, it is hydrolysis of sugar. Hydrolysis of sugar in the presence of sulfuric acid or H2SO4. So this is another example of homogeneous catalyzed reaction. Now we want to study the kinetics of homogeneous catalyzed reactions. Okay, so the reaction rate is the sum of rates of both the uncatalyzed and catalyzed reactions. What do I mean by this? Okay, let's say we want to react A and get the product R. Okay, so now this has one catalyst named C. So the uncatalyzed reaction is A gives R at the rate constant K1, and the catalyzed reaction is A plus C gives R plus C. C is the catalyst. Catalyst basically does not react itself, but it enhances the reaction process. So whatever catalyst is on the input side will be retained on the output side, and this, the first one is the uncatalyzed reaction and the second one is the catalyzed reaction. So like multiple reactions or parallel reactions, we have to write all the stoichiometric expressions to study its kinetics. Now the corresponding rate expressions are written. So let me label this uncatalyzed one as reaction 1 and catalyzed one as reaction 2. Then the rate expressions become, for the uncatalyzed one it becomes minus dCA dt, let me denote it as 1, equals to K1 Ca. This is fairly simple. For the catalyzed one, minus dCA dt 2 equals to K2 Ca into Cc. So now the reaction would proceed even without a catalyst present, and if it is the catalyzed one, then it is, the rate is directly proportional to the catalyst concentration as well. Okay, so if you want to now write the overall rate of reaction with respect to the reactant A, then you will write dCA by dt equals to K1 Ca plus K2 Ca into Cc, which simply means K1 plus K2 Cc whole multiplied by Ca. Okay, so this becomes your overall rate equation. Okay, now as usual we are going to integrate this by separating the terms, and the integrated form becomes minus ln Ca by Ca naught, or minus ln 1 minus Xa equals to K1 plus K2 Cc into T. This whole expression K1 plus K2 Cc can also be written as K observed or K obs into T. Okay, so this is how you will describe the kinetics of a homogeneous catalyzed reaction. Okay, now let's talk about the experimental perspective of this kind of reaction. So basically when you are studying the experimental data, you want to run the experiments for different catalyst concentrations so that we can determine K1 and K2 values. So first thing is run experiments for different catalyst concentration values. Only then you can get the rate for both the catalyzed and uncatalyzed reactions correctly. Next thing is we will do a plotting. Okay, so what plotting should we do so that we can easily get K1 and K2 values, right? So if you make a plot of Cc on the x-axis and K obs on the y-axis, you basically have a straight line equation. So you can get a straight line whose slope is K2 and y-intercept is K1. Okay, so this will give us the values of K1 and K2 individually. That is how we study homogeneous catalyzed reactions. Now this again is the basic of homogeneous catalyzed reactions. There are further studies for heterogeneous catalyzed reactions as well, but for a basic understanding of how to deal with multiple reactions when we have catalysts involved, this serves as a fundamental step. Okay, so you will write the stoichiometric equations for both the catalyzed and uncatalyzed reactions, and then you will obtain their kinetic expressions and use appropriate plots by taking the experimental data for different catalyst concentrations. Okay, that is it. Thank you.